Hello guys, today we are discussing about the introduction of the transistor, how transistor is to be worked, and what is the functionality, constructions, and what are the applications of the transistor. Basically, in this session we are going to discuss about the following these things: introduction, definition of the transistor, construction of the transistor working principle, and in last not least, application of the transistor. Now, what is the definition of the transistor? Transistor is a semiconductor device used to regulate current or voltage and act as a switch or gate of electronic signal. Now, transistor basically consists of the three terminals. It is used to regulate the current or voltage. Current or voltage. On other side, it is used to amplify the signal or work as a switching purpose in a digital electronics. This is the next era of basic electronics or digital electronics. Transistor basically made from the doped materials, means we can say this is made from the p or n type materials, which we have discussed in the construction or formation of the diode. These semiconductor we are already known about, that diode or transistor are made from the semiconductor material. The mostly the material which is used in the formation of the transistor is silicon. These concepts we had discussed in the basic concept of basic electronics when we had discussed the formation of the diode and construction of the diode. The semiconductor when doped then form p-type n-type material. As we know about the p and n type, how p and n type material is to be formed. Now, we are not going in detail, not discuss how by when we talk about transistor, we means that we are discussing about bipolar junction transistor. There are so many types of the transistor, but in the basic concept and basic learning we are going to discuss bipolar junction transistor. In next lecture and so on, we discuss further more topics of the different types of the transistor with their working principle and their applications. Now, this is the construction of the transistor, how transistor is to be made, what are the terminals of the transistor. Basically, transistor consists of three layers. One is PNP. On other hand, this is about when transistor is PNPA. Now, when transistor is NPN, means it consists of one layer of N, other layer of P, and other layer of N. Now, and on the other hand, it consists of three terminals. One is a emitter, other is a base, and other is a collector. Now, as from names, we have analyzed that the emitter is a terminal or the point from where the electron is to be emitted, and the base region is used to control the operation of the transistor. On other hand, in wider region or a reverse bias region is known as collector region. Collector region is used to collect the electron from emitter region towards base region towards collector region. It should be noted that the electron from emitter is passing towards base to collector. Now, these electrons which are emitted from emitter, 95% electron cross this base region to reach that collector region. It should be noted here that emitter is a highly doped region. Now, when we say that this region is a very doped region, means it consists of more majority charge carriers. Now, on other hand, collector is consist of reverse bias, means it consists of majority with a less number of majority charge carriers. On other hand, the base is a lightly doped region. What? Lightly doped regions. Now, emitter, base, collector. Now this is the cut view of the transition. These diodes are now how internally transistor looks like. Means two diode on a back to back two diode form the transistor. Now this is the symbol of the transistor. This is the cut view. This is the two diode analogy, and this is the circuit view. Okay. Now this is the emitter. Now this arrow shows that this is the electronic current flow from emitter towards base towards collector. Now this arrow shows that if this arrow, then we analyze that this is the common emitter or common collector amplifier. Okay. Now transistor construct is shown in above. Transistor consists of three terminals emitter. Now these are the terminals. One is the collector, and other is the base region, and other is the emitter region. Base, collector, emitter. Now how physically transistor looks like? Now physically transistor looks like that. It consists of the three terminals. Now by use of the emitter, or we can say that voltmeter, we analysis this transistor terminals, which transistor is by using multimeter we analysis his terminals. It is not in construction point of view that our base region is middle region. It may be this region or this region. It depends upon its resistance and or its construction. Now how transistor behave when it consists of the larger control current and a small control current. This is the large smaller control current, and this is the larger controlling current. Okay. Now working principle, it is noted here that emitter transistor heavily doped, so it consists of more electron. On the other hand, collector is moderately biased. Now we see that this is the emitter region and this is the collector region. Now as we have already discussed that emitter is heavily doped, so it consists of more charge carriers or free electrons. Now as we already discussed about, the collector is a reverse bias and it consists of less number of charge carriers. On the other hand, p-type material is a means base is a thin or lightly doped. Now electron, these things are discussed here in this theory. Now we can connect the battery terminal between emitter and collector terminal. Now these are the symbols of the battery, and this is the resistor. It should be noted that this resistor is used to limit the flow of the current across the transistor, because as we know that our electronic component are very sensitive. At the starting, if we supply more number of the charge carriers, then it should be may be damaged. So to avoid from these kinds of the things, we use the limiting resistor. Now emitter terminal connected with a negative terminal of battery, so emitter base region is forward bias. This is the negative region. Now this negative region. Now this is the NP. Now in the basic operation of diode, we have discussed that when Diode is connected with the emitter connected with the N type, and P type material is connected to the P type. So in this condition our diode is to be forward biased. Now on other hand, we have seen that collector means N type connected with the positive terminal of battery, and other hand base is a p type. So and this condition, one junction which is found between the base and the collector region is a reverse bias. So as we have already known about the reverse bias condition, is that our depletion region is to be wider. On other hand, when transistor one junction is forward bias, so at the forward bias condition the depletion region is narrow down. Okay, now these are the separate symbols of transistor. Means the black shows that this is the electrons. On the other hand, this blue color holds representation of holes. Now it should be noted that entire voltage not on drop. Now here we see that entire volt one consists of p and p junction. Okay, now this is the forward bias region and this is the reverse bias region. Okay, now if we want to cross this region and started the conduction across the transistor, then we should supply 0.7 voltage, which is also known as barrier voltage or barrier potential, to overcome the depletion region and allow the electron transfer from N to P type material. Okay, now we have collector region and a P region. We already discussed about that. This region is a reverse bias region. So to overcome this region we apply higher voltage. Means we have two kinds of the drop voltage, one at forward bias condition and other hand it draws on a reverse bias condition. Okay, now it's noted. Now when we now here is the picture we show that it should be noted that 95% electron transfer from this emitter region towards collector region. How much? 95 percentage electron are whole. And we when we NPN in the condition of NPN transistor, the electron 95% electron transfer from, this is the emitter region, this is the collector region, this is the base region, this is the supply voltage, and this is the VBE or base voltage. This voltage is used to control the whole operation of the transistor. Okay, this is the supply voltage which is used to represent that emitter is heavily doped and collector is a reverse bias by connecting their terminals. Here we see that this is the positive terminal of battery is connected to P side and negative terminal of battery connected to N side. On this situation, the diode is, our transistor is a forward bias condition mode. Okay, now now collector, these are the application of transistor. Work as amplifier, work as switch, digital logical design and IC manufacturing. Now if you have any question regarding this, you may ask on my email address or my WhatsApp number. Thanks for your watching.